Hello, can you try this question? The question says, find the number of stereogenic center and stereoisomer that we can find in this compound. Now, your stereogenic center is otherwise known as your chiral center. Now, this video is for all undergraduate students offering chemistry and for aspirants. It's your favorite chemistry tutor, pharmacist Joseph. Now, I'm going to walk you through how you go through questions like this. Just ensure you copy this down, draw this structure. You are going to answer this question yourself. Now, I'm going to rub this off and teach you how you go about questions like this. Firstly, if you are told to look for your chiral center, you pay attention to the carbon of the organic compound. So we pay attention to the carbon of the organic compound. Now, the first rule is that your carbon, if it's going to be a stereogenic center or your chiral center, your carbon must be sp3 carbon, meaning that carbon is having 4 bonds around it. It is sp3. The carbon must be sp3. The first thing you must understand, if you have to locate your chiral center, which is your stereogenic center, your carbon must be sp3. We are having 4 surrounding it. Now, the 4 elements or substituent, the way you want to call it, surrounding this carbon must not be equal, meaning that A, B, let's say X, and Y. So, firstly, it is an sp3 carbon with 4 bonds around it, and I said the elements must not be equal. So A is not equals to Y, Y is not equals to B, B is not equals to X. Now, with this information, we can easily locate our our chiral center. Now note that once you get your chiral center, you can easily get your stereoisomerism, because the formula says 2 raised to the power of n, meaning that the number of chiral center present in that compound is your n. So if the number of chiral center is 1, you put 1 here. If it is 2, and like that. So let's try a question. Let's assume we have C. Pay attention to this. Let's assume we have C. Not to waste much time. Yeah. Let's assume we have C. We have H. We have H. We have C. Then we have OH. We have H. We have, let's say we have C, H, because of our time. Then we have H. Now, let's take a look at this compound. Now, firstly, the rule says you try to look through all the carbons of your organic compound. Now, let's try to start from this. This guy is having 1, 2, 3, 4. It is sp3, but the second rule says that the substituent on them must be different. You can see this is having hydrogen, which means it is not a chiral center. The substituent on it must be different. Everything. Now let's look at this carbon. This carbon is having hydrogen, is having OH, is having the whole of this, which is CH3, and is having the whole of this. Meaning that this carbon is 4. We have 4 around it. 1, 2, 3, 4, and they are all different. This guy is a chiral carbon. It's a stereogenic center. Now, if you take a look at this, it's having hydrogen and hydrogen. It is not a chiral carbon. If you take a look at this, it's having hydrogen that are the same. It is not a chiral carbon. So how many chiral carbon do we have here? We have 1. And if the chiral carbon is 1, which is your stereogenic center is 1, we can calculate our stereoisomer. So from here we can say, since stereoisomer says 2 raised to the power of n, n is the number of chiral center. How many chiral center do we have here? We only have 1, which is this carbon. So we can easily say 2 raised to the power of 1, and your stereoisomer will be what? 2. So this compound has 2 stereoisomer. Now with this that I've done, I want you to try a question yourself. Try this question. We have CH3. Let's say we have CH2, we have C, we have OH, we have Cl, we have C, we have H, we have H, we have C, we have Br. Let's make it a little bit complex and simpler. Let's say we have OH, then we have C, double bond O, OH. This is an alkanoic acid. Now, I want you to try this question. How many stereogenic center, which is chiral center, we have here? And if you've gotten your chiral center, I want you to look for the stereo isomer. Now, the structure I gave you in the beginning of this video, I want you to also try it. Note that many organic compounds with chiral center or stereogenic center, most of them are optically active except for meso compound. If you have any question related to chemistry, you can ensure to reach out to FarmJo. Ensure you do your assignment, send the answer to the comment section, and ensure you like this video so that you get more content like this